Hi, Team Shetland Attack Pony Mobile here, and I'm going to talk about the eco-disaster code that we created for PiWars. So the challenge eco-disaster was to collect 12 barrels, 6 red and 6 green, and the red ones needed to go in the yellow zone, and the green ones needed to be picked up and put in the blue zone. And they gave us brilliant measurements and exactly what needed to be done. We were very lucky to be able to 3D print some barrels. They're not the exact colours, but you can see that one's white that we sprayed red, but that's fine, you know, we just needed it for demonstration purposes. You get 250 points according to the rules just for even attempting this autonomously. So we thought, yep, we're going to try it. Because even though this is a fantastic feat of engineering and electronics, our strengths are actually in programming. I have a degree in computer science. I'm a coder. This is my bag, you know. This is what we were really excited to try this challenge out in Python. So what we started with is we didn't have an arena, so we didn't have a space big enough to assemble an arena to kind of test the code fully. So we decided to make a simulator. So we were able to do a simulator in Python, and we had two views. We had a top-down view, so you could see Shetty moving along, picking the barrels, moving them to a different zone. And then we had a 3D view, which is what it looked like from the camera point of view. And these just look, I just think these look really cool, and I could watch these for hours. Then the simulator was brilliant for debugging. It was just fantastic for being able to run it, debug the code, start again. Then the builders were coming, so we had to clear out our basement. And suddenly we had this floor that's about to be ripped up and that's empty. So we very quickly threw together an arena and created the actual arena and put down the barrels, printed more barrels, and got the robot to move around and do it in real life. Did the arena match the simulator? No, it did, it really did. In some places it was just perfect. It was really hypnotising to watch the simulator and then the real world reenact the simulator. Just certain things we never quite got working, like Shetty's arse always seemed to, it never knew where its arse was, so it would spin and it would knock over a barrel in the simulator, and the simulator would be like, that's fine. Well, obviously in real life we had barrels rolling everywhere, so it was really fun but frustrating to watch that. And that's how we tackled this challenge.
So let's look at the code. So I started, we've got a main class, which is what gets run when the Shetland Attack Pony starts up, and that is involved with managing the menus on the front of the pony and receiving all the key presses and all the other bits and bobs of housekeeping. And it also starts one of several different modes that the pony can be in. So there's one mode which we use for doing the eco-disaster challenge, one mode for the minesweeper challenge, and there's also one mode for just manual control for the assault course challenge. These all connect onto a single unified hardware class, which within it has several different subclasses. So there's a laser subclass, which is responsible for the laser rangefinder. There's a camera subclass, which can be used to access images from the camera, and there's a driver class, which is how it controls the motors. And these then obviously interact with the real world. And obviously the real world has an impact on those back again. So it has an effect on the drivetrain in terms of how far the thing's actually gone. And it also has an impact on the camera because, you know, you get different pictures depending on where you are and what's just happened. So what I've done to create the simulator is to create a completely separate hardware class which has all the same functions and parameters as the normal hardware class, and this is a sort of simulated hardware class. So this also has a laser submodule, a camera submodule, various other bits and bobs. I've then created an arena class, and this kind of represents the real world. So within the arena class, we've got barrels for the eco-disaster challenge, and there's also a representation of the Shetland attack pony itself, just keeping a record of where it is, what direction it's pointing, how fast it's going. And then there's two separate libraries that are used to model that. One is a 2D library, which we use for the top-down view. And there's also a 3D library which we use to generate the images for the camera. So the 3D view then feeds information back to the camera, which can then feed it into the OpenCV image recognition software. This means that I can design one mode that just represents how we solve a particular challenge, and it should work exactly the same in the real world as it does in the simulator, and I don't need to have different code for that. And that's about it.
Let's show you the simulator working. So on the left we have the 3D view, what the camera sees. On the right we have a top-down view. So the first thing we do is we scan the arena and find all the barrels. The cross is kind of where it thinks the center of each barrel is. Then it creates an octagon around each barrel. And the center of the robot, you see the octagons now, should not go into those octagons. If it does, it's probably likely to knock that barrel over. Here's a quick demo. We also use a simulator for this challenge, Lava Palava. And on the right is the map of the course, and on the left is what the camera sees. So we never got to test this one out, but it was also a good simulator, one to use with the simulator. Here we have eco-disaster working in real life. So it's going to scan around the arena, find all the barrels and start collecting them. I'll let you enjoy the rest of the video.
Yeah. No. Yes. One. That's 100 points, right?
Yeah.
Yay! 2. In 2 minutes.
Yeah.
Okay, so we should get 6.
Maybe. Oh, for heaven's sake, it was just there. It was there. You were looking at it. It was there. What's wrong with you, you muppet? Not very clever.
Oh! Ugh, my heart every time it grabs one. Yay! 3 in 3 minutes.
Yeah.
Oh.
Yeah, got that one.
Oh, what's yours? Where's it going?
Over there.
Oh, wow. 4 in 3 minutes. 20. Yeah. Oh, this might not be so bad then.
Yeah.
Except there'll be...
It needs a bit more fettling.
But there'll be a lot more barrels on the stage. It might knock over a lot more.
Yeah, but it might knock more over into the correct zones.
But they have to be standing to count, don't they?
Yeah.
It's dancing. It thinks it's over.